we can move on to chapter 2 and first part. So chapter 2 is divided into 6 parts. Tyler is coming again today. He's busy today. Right. So the book is made of 8 chapters. According to my revised schedule, we will cover a whole book instead of covering the other book. I changed the schedule. Okay, and then this chapter is going to talk about design itself. So how can we model the design, the engineering design? But it should be knowledge-based model. Okay? So how can we model the engineering design in knowledge-based way? So in chapter 2, I will cover the first section. There is a representation. So how can we represent a design, right? Design into a computer? So we should, inside computer, everything should be represented as numbers, right? Bit numbers, 0 and 1, right? At the final level. So we should convert somehow to numbers. And then the book says we divide into or levels of representation. So we start from fact. Fact is it is real world things. The existing ones, the true ones, and datas, right? Data, fact. And then, based on fact, we can make a knowledge. And then how can we represent a fact inside the computer? Also knowledge. And control is also one level up of knowledge in this book. There is a concept. And fact is made of object and relation. So object can be the bottom line in here. So object can be a basic unit of information inside knowledge-based representation of design. Right? So for example, designers, engineering designers, object can be entities of lines, face, or blocks, or rectangle, right? Or desk. So in a drawing, you can say in a drawing or CAD model, the object can be geometrical entities. And fact is made of object, but again, the fact can be another object. So it can be a recursive representation, so that we can make a bigger assembly out of them. So we can say there is a hierarchy, or we can say this kind of a nested fact, so that it grows into, it can represent complex object. And LISP is a programming language for AI, artificial intelligence. And in LISP, they define that atom is the fundamental object in LISP. So once again, the object can be atom in LISP, but same as basic unit for representing knowledge and fact. Right. And then this is a sample of facts, object and relation. Right. So first one is a piston valve is inside combustion chamber. There is a fact. There is a two object appearing, and relationship between them. Right? So by representing relationship between object, we define a fact. And second one shows that dining room inside the apartment, dining room is next to living room. So this can be a designer's object or fact for mechanical engineering. Right? This is architectural drawing, design. Right? Once again, this is also automotive engineers. here the drive shaft is longer than rear axles. Driving shaft. So factors can be represented by object and their relationships. And I found this picture from Google yesterday, and they are saying that this is probably a personal name, and he is trying to mention that Lisp language can be implemented based on Python language. So anyway, you can think about there's some relationship between programming languages. You can find more on this. And then it started from object and fact, and then arrive at knowledge level. So knowledge can be a statement about mappings between fact. So relationship between object can be a fact, and then relationship between fact can be a knowledge. So mapping can be a relationship, or sometimes it can be a knowledge itself, enabling us to derive a new fact from the existing. So knowledge can be a rule, simple rule, right? If then this is a rule. There is a different ways of types of knowledge. The simplest one is if then rule, right? So if the fact is true, then the second factor, say if A is true, then B can be true, right? So we arrive at new fact from existing fact, right? Because of this rule. If the rule is working, okay, or knowledge is working. So that we say our logical connections between fact can be a knowledge. So and or if or conjunction and disjunction. And control, the third level of fact. So knowledge is relationship between fact. And then once again, control can be a relationship between knowledge statement. So sometimes we can say it's a process. All right. So we start from control and object, and then relationship between object, we define a fact, and relationship or mapping between a fact can be a knowledge, and then relationship or mapping between knowledge can be a control. So there is a hierarchy of representation, and there is another programming language called Prolog. This is also used for AI engineers for programming artificial intelligence, as is a short name of programming in logic. Anyway, once again, the object and their relationship gives you fact, and then knowledge is a relationship between a fact, and then controllage can be a meta-knowledge. So knowledge is combined or mapped or related into a control. So we can say this is a meta-knowledge. Right? In tabular form, so the object gives you a fact. So fact is made of object relationship. So there is a sample of objects or types of objects, such as class, attribute, or variables. So real example can be a chimney, car, roof, and house here. And so before we say the room, living room, or piston, or crankshaft can be an object in examples above. And relationship between object can be, say, object groupings or topology. Or topology example can be on and above. So chimney is above floor, something like that. Okay. And then in a hierarchical way, the relationship between fact can be a knowledge statement. So example can be one statement like this one. A is on B, A is above B. So relationship between facts, right? And then the logical connection can be, say, here you can say if and or. So if A and then B can be a sample knowledge statement. Okay, and then the higher level, there is a control statement, and components can be a knowledge statement. So, and examples can be above and on. No, there should be a control state relationship between them. Their relationship is should be here, but I cannot see the relationship. So you can see. Right. You can find, no, I cannot see that. Above Z and Y can be figured out. I don't know. Anyway, so we say this can be a meta-logical connections between knowledge statements. Right. This is a book cover of coming from Springer, and that shows a Prolog programming, logic programming with Prolog. So Prolog is a kind of another programming language for AI. And finally, there has been a question from Youngi last time. What is a meta? And also we saw there's a meta control or meta knowledge here. So from Wiki, they are saying this is after or beyond the meaning of this. So concept, which is an abstraction behind another concept. So I explained at the time, it's a metadata. It is data about data. Right? So you can say this is one higher level of abstraction. So grammar can be also as a meta language. That is the samples. One more slide coming from here is the picture of meta level. So it is a kind of beyond or above abstraction, higher level conceptual or generic concept. And process, we say process, but this is development, the real world, what happens, and that the way the work is going on in process, and then there is a meta process. So sometimes we are dealing with conceptuals in higher levels, hierarchical levels. So we use meta in this way. Right? Questions? No questions. Then we go on to second part by once again invite the Thai presentation. 또 도와줘야 될 것 같아.